LeetCode Problem number 62, unique paths. So there's a robot on a m times n grid, and a robot is initially located at the top left corner, which is at grid 0, 0. And the goal is that the robot move to the bottom right corner, right, which is m minus 1, n minus 1. And the robot can only move either down, right, at any point of time. So it cannot move up, and it cannot move left, right? It can only move to the right and move down. So given two integers, we have to return the possible number of unique paths that a robot can take to reach the bottom right corner. And this is just some further information about how the test case will be. So my approach to this problem is to use dynamic programming, and I've chosen to use a one-directional array instead of a two-directional array because I've noticed that I can just iterate through the row while I calculate the unique paths it will take and just put it inside this dynamic programming vector. So I'm going to use the example given. Let's say m is 3 and n is 7. So my dynamic programming array will look like this with 7 ones. So what this means is from this robot spot, it will take one step to no, not one step, but there's only one possible number of unique paths to reach to this box, right? And this box, because this is only we are only calculating one directional for now, a 1D array. So it makes sense that there's only one path to reach all the boxes to the right. So what I'm going to do is I have to iterate through the rows and then calculate again. So you notice I'm starting from 1, skipping the first. So I'm skipping the first row. So I is 1 and j would be the index calculating for the column, which is 1 as well. So what I do is, so for instance, let's say I1 and j is 1. So we are looking at this box. So for this box, we already know that there is one path to reach this box from the top. And so now we have to add one more from the bottom, right? Which is why we add the 1 from before, which is 2. Okay, so let's say for this box, the reason why it's 3 because there are 3 paths to reach here, right? There's 1, there's 2, and the third one, 3, right? So if you notice, we have passed through, to reach this box here, we have passed through here, right? We have passed through here. And we already know there's 2 paths to reach to this box, right, from our previous calculation. So since both of these can pass through here, we only need to add one more from the top, which will give us the number 3. Okay, same things for this box, right? Same thing for this box. We have passed through here, and we know that there are 3 paths to go to this specific dot to reach to the angle, and now we just need to add one more from the top. Okay, the same goes for all the previous, for all the remaining boxes, right? So now, at first iteration, the first row, for this box, there are 7 possible unique paths to reach this box. Okay, let's continue. So now I is 2. We are now focusing on this row now, the last row. So again, we do the same thing. We add the previous number, or more like the previous unique paths it took to reach to the previous box we had, so over here. So again, we add up. So 3, this will be 6. Okay, just to confirm, this is 6. So for the robot from this box to reach this box here, there are 6 paths. So there's 1 here, 1. There's another one here, 2. There's one more here, 3. There's 1 here, 4. 1 here, 5. 1 here, 6. Okay, so we're on the right track. So basically we do the same thing for the rest. 10, 15, 6 plus 25 is 21. 21 plus 7 is 28. So once we're done with that, I has reached I is no longer more than m. If we increment I one more time, basically we've finished iterating all the rows. So here we just return n minus 1, which is the last box, which is the angle as well. And if you see here, it is 28, which matches the output given in the example. Okay, so this is a pretty straightforward problem, and my answer is pretty straightforward as well. That's all I have to show. Thanks.